Hello, in this video I am going to explain a very important concept of a new data type that is a list data type. So this is used very often in programming when we want to model a collection of things, not just one number or not just one string, but many of them, and we want many of them to be collected, in some way connected all together in a collection. Okay, so let me show you what in this one. The same it's going to do the same thing that I just showed you in the previous video. It's going to go change colors, the same 5 colors that we had before, but now it's going to do it in a different way. Let me show you. So what's going on in here is that instead of having a bunch of variables, each one with a name that has, black, white, green, etc., what I'm having here is a list of colors. So what is this? So list is a keyword. That's my data type, a list. This is the variable name, colors. And the way that you construct a list here is with this square brackets. So whenever you have square brackets, it's a list. And inside you have the elements separated by commas, right? So in this case you have these vectors, a list of vectors. So here's a vector, here's another vector, here's another vector. So those are the colors that we want. Notice that we don't have the names of the colors here anymore, but it doesn't matter because we don't really need the names of the colors anyway. And this could be, many variants of red, green, and blue. So this is a list that I'm having here with 5 elements, 1, 2, 3, 4, 5 elements, and there's the counter here again. In the beginning, so when this compiles or resets, the color is set to the first element of this list. So this is how do you get at the elements of the list, is with these functions of that virtual gives you, which is LL list to something. We need to know what types of things are inside the list. So in this case, it's vectors. So we say LL list to vector. Of the list colors, and this is an index. In this case, it would be the index 0. So that's the first color. It's that first color over there. That's going to be white. And then every time that we touch the object, we increment the counter up only to a certain number. And what is that number? Is the list length. Right, and again, another function by the virtual gives us that LL get list length, gives us the length of a list that we are asking about. And so this is only, it goes from 0 up to the list length and then goes back to 0 again. And then again, this is how we get certain colors. So a vector, a color is a vector, and again, LL list to vector the list colors with the index counter, right? This counter, and then we set the color for that color. All right. So now, as I said, it's the same thing that we did before, but instead of having that very long list of global variables at the top, each with a name, we now have all of those colors in a list. Each of them does not have a name. It just has, we get to it by index. So it has a certain position on the list, and that's what matters over here. All right, so lists are super important. Let me show you. This one has a list of, let me reset this, a list of words, and it's going to do the same thing. So this is, instead of colors, it's just a list of words. I think it's 5 words or something. Okay, just go flipping through them. Let me show you this one. All right, so here's the list, and now my variable is called words because it's words, and so inside now it's not vectors, it's strings. Okay, that's what I said, that it's a list of some type. In this case, it's a list of strings. It's also five of them, and I'm doing the same thing. So how do I get to each of them? Because these are strings, I'm going to use LL list to string, right? In the previous script, I was using LL list to vector because I was dealing with the colors that are vectors. These are strings, so I LL list to string of the words list and at position counter. and now I get a specific word and I print it out, right? So super important. Okay, so next I'm going to explain to you another thing that I think is important here. Um, I'll come back to lists, but before I go, I want to show you how to make these objects listen for input. So things that you type in the chat, and they can listen to what you type and do things based on what you just said on the chat. Okay, so let me show you what this is going to do. I'm going to click and it says now listening on channel 0, type something in chat. So if I type something, for example, hello world, it's going to echo it back to me all in capitals. Okay, so if I say Crystal Lopes, it's going to echo it back all in capitals. And so if I do here, let me show you what this does. So the way that this works for listening is I have when I touch it, I'm going to remember what was the avatar who touched it, so the identification of the avatar, and that is given again by the virtual world LL detected key, gives us a key or an identifier of the person who touched it. And then I'm going to do, this is important to remember because when I click it again, then or when I say something, I want to listen only to that avatar that clicked the object. So the way that I'm going to start listening is by calling LL listen, which is a function of the virtual world. It tells you in which channel, so channel 0, and it has some parameters. But more important, it says that its message is from this avatar, not the other. So if other avatars also say things in the chat, this object's not going to listen to those other messages from those other people, only from this avatar, right? So the LL listen gives us a number, a listen handle, and that is greater than 0. And so I initialize it to, if it's 0, it's because it's not listening. And when it's listening, this switches to some other number greater than 0. So what that means is that if I touch it again, then this part runs, and then I remove the listen, and I set the listen handle back to 0, and then it stops listening. Okay, so this is just to start listening. So what happens when when the person actually types something on the chat? Then in that case, is this other event that is a new one I hadn't told you about. This is an event that happens when a message is typed on the chat from this particular avatar, according to what we have here. So in this case, it gets, gets this event telling in which channel it was, the name of the person, the identification of the person, and the message itself. Okay, so all I'm doing here is that I take the message, I'm transforming it to uppercase with this function LL2 upper that puts everything in uppercase, and then I'm writing down on the chat the result of uppercasing the message. All right, so that's what is going on in here. So stop listening. If I start listening again, hello world, it gives me back all in capitals. All right, stop listening. This one does the same thing. I'm coming back now to lists. This one listens to in the chat when I type it, when I click it, but now it's going to capitalize the first letters of every word. So this is a little bit more sophisticated. Let me show you. So if I say listening and I say hello world, it's going to echo back hello world, but every single word, so it has to identify the words now. It's a little bit more complicated. It has to identify the words, and then it has to capitalize the first letter of each of the words. All right, so let me show you how this is done. So the mechanics of listening are the same, so I'm not going to explain. This part is the one important one. So now, I have a message which is a whole string, and out of this message I have to identify the words. So how am I going to identify the words? I'm going to look for the spaces, right? And so there is a function here in the virtual world that does that for me. It's LL parse string to list. It gets a string, a whole string, you know, with spaces and characters and punctuation and stuff, and it gives me back a list of the words separated by whatever separators I want to tell it. So in this case, I'm just saying that I want to separate with the space only, right? So given a space, that's the separator of the words. So this gives me back a list of the individual words, okay? And so then I am going to construct another list of words that has going to have the words in the original list, but with the first character capitalized. So how am I going to do that? So I'm going to traverse through the original list of words, so from 0 to the end of the list, so that until the size, the length of the words list. And for every I, right, as I'm traversing this list and incrementing the I, I'm getting a word, right? So here's the first word at 0, the second word is at 1, the third word is at 2, etc. And this is done with the LL list to string, because this is a list of strings. So I get a word, and then what am I going to do? I want to capitalize the first letter. So I'm going to get the substring of the word. Okay, so it's a one individual word at position 0, 0. So this is basically the first character of the word. Okay, that first character of the word, I'm going to transform it to uppercase with LL to upper. Right, so it says that one character is LL to upper. And then I'm going to join that with the rest of the word. So what is the rest of the word? Is the substring of the word that starts at index 1 and goes until the end of the word, -1. All right, so it's the uppercase of the first letter plus the rest of the letters of the word. And then I have this word that has the first letter capitalized. I'm going to add it to the list, right, that I'm constructing. So the list in the beginning is empty, and then I'm going to add this word. And then when on the next iteration, it's going to add the word to the end of the list. So the plus, we've seen already the plus with many meanings. When you have a number, the plus means that it's the addition. When you have strings, the plus means that it's the concatenation, the joining of the strings. When you have a list, the plus means appending, so adding one list with another, so joining the lists together. Okay, so that's what the plus means. And so I'm constructing this new list that has all the words with the first letter capitalized, and then at the end I'm going to write it down. And I'm using this other function that is sort of the inverse of parse string to list, that is dump list to string. So given a list, it produces, because giving a list of strings, it produces a string where each of the elements of the list is separated by whatever we want. So in this case, we just want to be separated by a space. Right? So we had a list of words, and now we're going to have a big string with all of those words separated by something. In this case, we want to be separated by a space. It could be separated with a, for example, with an asterisk or 2 asterisks, for example. In this case, it would be do something like this. Look. Hello world. Oh, I have to make it listen first. Was it this one? No, this one. Okay. Hello world. There. In this case, it puts the 2 asterisks over there. All right. But I wanted to put the space, so let me put the space back again. All right. I say hello world. There. It gives me hello world with the space in between. Okay, so all right, next one reverts the strings. So if I make it listen, I say 1, 2, 3, it gives me back 3, 2, 1. So how does it do that? Going down here, so this is pretty much the same thing that we had before, the parsing the string to a list. And then what this thing should not be called words repeat. It should be called words reverted. Sorry, misnomer here. So what I'm doing here to revert the list is that instead of adding the word to the end of the new list that I'm constructing, I'm adding the new word to the beginning of the list that I'm constructing. So basically, the newer, the later words are always coming into the left of the list, always in the beginning. So that's why I'm able to construct, revert the list. Okay, and finally, this one finds a word. Okay, so this one, let me reset this. Um, this one already has a bunch of words inside, and I'll show you what it is. And then if I search for a word, for example, design, I know it's there. It found the word design in there. If I search the word, Krista, it's not there. It's not found. So it's a search. So here I have a big sentence with lots of words inside. And the first thing that I do when I compile or reset is to parse that big sentence into a list. So splitting all the words, and this time I'm splitting on more separators, not just on the space, but also on the dot, for example. I want to get rid of the dot, the dash, the comma, for example. So all of those are separators too, and this gives me a list of the words, and then when I listen, I'm going to call this function list find list, which is something that already exists and finds, tries to find this list in this list. So the message in this list, and if it exists, it gives us back an index that's greater or equal than 0. If it doesn't exist, it gives us a negative number. So that is what is going on in here. In the quiz, I ask you, other ways of doing search without using this function. There are many ways of doing search too. With just the repetitions, iterating through the list by ourselves, right? We'll go from one element to another to check if it's similar, if it's the same as the message that we heard. Okay, so that is about that is it. This one collects from the input from the text chat and then searches over the words that it has heard so far. All right, so I think this is it. Good luck with the quiz, and I'll see you in class.